This video is about Firefly Host. I'm going to cover some of the architectural details around the solution, have a few slides that give you some details around how it is installed and the main components and the main elements of the solution, a few of the various features. Then I'll turn and do a demonstration with the web interface of the product to give you a lot of more detail and a much better feel for how it all operates. So at a very high level, unlike Firefly Perimeter, which is a firewall in a VM, and there's another video on that solution, Firefly Host is a combination of a set of VMs that act as infrastructure VMs and a set of kernel footprints and kernel components that are used to enforce the security policy on virtual machines. So from a very high level, right now we support VMware and we use VMsafe. And as we transition to the new architecture, VMsafe is being replaced by NetX APIs that are available in NSX, and we'll have a version that supports that later in the year. For now, you can operate on the VMware platform as is. There are three major elements to the solution, and the first part is a management system. It's just like Virtual Center. It's a VM that can exist anywhere in the infrastructure. We use a set of different APIs called VI APIs that are used to communicate between Virtual Center and what we call the Firefly Host dashboard, or also just called our management center. So our management center communicates with Virtual Center, and that's important because we want to be able to know when new VMs come online, or want to be able to automate the deployment of our infrastructure. And to do that, we need that API integration with Virtual Center. So that happens. That's kind of tier one, and I'll talk in detail about what that management VM looks like in the next couple of slides. The second part is on each physical host, we deploy what's called an SVM. So that orange VM that you see here in this diagram, that is responsible for getting the management information and then pushing it to the third component, which is the actual enforcement engine. Today, that enforcement engine is in the kernel. It's Juniper code. We program that with our firewall rule sets, and then the traffic is enforced on the VMs. Going forward, we'll use VMware's NSX infrastructure there, program that kernel footprint with our tools, and then that will be the enforcement layer. But in any case, the functionality and the way that this all works is when VM1 wants to talk to a physical server, or when VM1 in this example wants to talk to VM2, it goes down from the virtual NIC to that enforcement layer, and then from the enforcement layer to the virtual switching layer, and potentially out to the physical switching layer if that's the flow of traffic from virtual to physical. If it's virtual, then of course it would stay on the vSwitch the entire path there. For example, in VM1 to VM2, it wouldn't leave the hypervisor in this state, but the engine is in that kernel and enforcing it. That's how we get the very high speed performance, and that API integration is how we get the visibility that I'll demonstrate as we go along here. So these are the main modules. A networking module gives you the insight into the traffic flows. The firewall module, global group, individual VMs, IDS, Antivirus. I'll go through these in the user interface in a few minutes. I do want to talk a little bit more about the architecture of the management VM. Diagram depicts a couple of important pieces. So on the left-hand side, imagine that this whole Firefly Host dashboard is just a virtual machine. So it's a virtual machine. It's got a Postgres database inside of it. It's running a Linux operating system and a web interface, and it's all contained in a single VM. It's about 4 gig of memory to it and a user configurable disk size, so 40 gig, 100 gig. And that disk is going to hold the policy database information, the configuration information, as well as logs and NetFlow. Of course, if you get to be a larger infrastructure, you're going to want dedicated devices to hold all those logs and NetFlow information, and you don't want to just hammer your management VM with that information. So we have connectors on the right-hand side of this diagram, NetFlow and syslog, where we can send the logs out to these devices. We also have an alerting engine on that right-hand side so we can notify other things, send an email alert, send a trap out to something else. So that's part of the diagram. On the upper left-hand side, you'll see two important pieces: the administrative interface, which is just a web UI, but also an XML RPC connector. So we have a set of APIs, and you can programmatically change things just as easily as you would sitting down in front of the GUI to alter something. Now, some of our customers have gone out and built entire ecosystems and sets of applications and portals and so forth around those APIs, and so they present to their end customer a product that doesn't say Juniper anywhere in it. It feels like their own portal within their cloud infrastructure to onboard a VM and then just assign a security policy to it. So all that capability exists within that user interface. On the right-hand side, you can see that VI API connector that I was talking about, the communication into virtual centers, so we know what's happening there and we can make smart policy decisions based on that. And then we have a lot of engines that basically manipulate data and manipulate XML constructs for our policy enforcement, all of that kind of reading and writing into the database, making it so that we can also communicate out to our what we call our SVMs. In that last diagram, that orange VM that was deployed on each one of the physical hosts, we put that out there in the management system, and it has to communicate with those individual SVMs that are all deployed, one for each physical host, so that it can communicate to the kernel module. That happens with a connection. Of course, that connection has to be secured, so we have a certificate authority in this so that we can encrypt all that traffic that is flowing from the management policies and so forth out to the SVMs in the environment. So that's all done in a secure fashion. There's some time stamping and time services here, and of course that certificate authority to encrypt that traffic. None of this stuff is really anything you have to set up. It's just described here to give you a better understanding of what the management system is actually doing under the covers. The database is already pre-installed. The web server is pre-set up. You don't have to do anything on the certificate authority unless you wanted to add your own certificate to it. All pre-baked. That's the beauty of virtualization, right? There's some ports here that need to be analyzed when you deploy this. But overall, very easy to deal with the management system. You can have redundancy on the management VM, active standby on the VMs, and you can also deploy multiple VMs. We have something called multi-center and split center, two options to build out many VMs, management VMs acting to support very large deployments. Now, that SVM, or that thing that's installed on each one of the hosts, what's that all about? So you can see here, this is an ESX host, and there's kind of the upper half and lower half. And the upper half is really literally a virtual machine. So the items in that orange color are the functionality that's happening in the security VM. So in the security VM that we deploy on the host, it's about 2 gig of memory and a very small disk. So this doesn't need a big disk. It's about a 2 gig disk in order to just basically run the Linux operating system there. So that VM is responsible for a couple things. So if you look at the diagram, it's responsible for talking to the host dashboard of the management VM. So there's a connector in there. And it's responsible for taking the XML policy that it gets from the management station and then injecting that into the lower half of the diagram, the ESX kernel, where our actual enforcement engine exists. And I'll talk about that in a second, but just know that that's one of the things it has to do. And then it also is where AV and IDS signatures reside. So there's a set of signatures that reside in this infrastructure, and there's one set of signatures for all the VMs that exist on this host. So you deploy a single security VM, there's 50 other VMs on that server that are your web application, your database app, whatever your guest VMs are. And those guest VMs don't need to have their own AV or IDS signatures for each one of those VMs and create a bunch of bloat in the deployment. Rather, what we do is we create one set of signatures on the security VM, and that is enough to serve out a handful of VMs, 50 VMs, 100 VMs. It's all very much a rounding error. So you can see that we we are able to scale out the infrastructure because we install these signature sets on each one of the actual physical hosts. You can see that the SVM is also able to send to a NetFlow device and a syslog device itself, right? And so again, you don't want to funnel all that logging and event flow information all funneled all the way back up to the management station. Wouldn't make any sense. You would just overload the management station. Even if you weren't dumping all the logs there and you were using it to connect out to the other SIM and NetFlow style devices, the idea to disperse that processing in the infrastructure exists. So if we see a VM that's trying to communicate, it creates a bad log, then we can send it right into the SIM or the NetFlow collector right off the bat and not have to worry about it. So the second part of the diagram, the lower part in gray, is where we have a kind of the heart of the beast, if you will. So here's where we're actually instantiating logically different firewall engines for each virtual NIC. So every VM that comes in that you decide you want to protect, and a VM could have one-to-many NICs in it. And maybe you don't want to protect all the VMs, or maybe you do. It doesn't matter. Each VM's NIC that you decide to protect, we instantiate a chunk of memory where we keep a rule base for enforcing the rule on that traffic flows for that NIC, and also a connection table so that we can establish a session and do the processing on that. And then we bundle that so that it's isolated from other VMs, and also if a VM moves, of course, from one server to the next with vMotion, then we can deal with that. We bundle that connection up and we move it along with it. So in this way, we have the majority of the heavy-duty processing happening in line. The AV and IDS signature sets, that's out of band. It's happening on a kind of a copy of it that it's not holding a connection. The firewall, if you don't go fast enough, you will impact the user experience on the VMs or the app experience on the VMs. Whereas with the IDS engine, it's IDS, not IPS, so it's not in line. It's operating on a copy, so there's not as a significant penalty if you queue up and kind of work through a queue from IDS events. So this is all the infrastructure here. This will change with NSX a little bit, and we'll share more information around what that looks like. But the overall kind of configs and pieces we plan as is. There's a whole white paper on this, a whole white paper talking about the flows and that kernel module and that infrastructure. You can get that white paper off juniper.net/Firefly, and just go to the Firefly Host piece to get that. Lots of detail there. There's also an antivirus performance paper talking about why it makes sense to not do 50 different signatures databases, 50 VMs getting updates, 50 VMs chewing RAM, 50 VMs chewing CPU cycles for each one having a whole thick antivirus client. So we can get rid of that. We do have some integration with the physical SRX as well, so we're blending virtual and physical together. So customers are somewhere in the middle of that spectrum, or somewhere on that spectrum, maybe not necessarily the middle, between being virtualized and running a physical infrastructure. And we know that there's security on both of those areas that are important. We have a goal and a set of tools with Security Director to manage virtual and physical from one spot. Firefly Perimeter is already exclusively using that tool set, and Firefly Host has some different elements in its management right now, but over time it will be all folded into that as well. And don't forget, we have other products within the security group at Juniper, Secure Analytics, to do that offloading of NetFlow and syslog information. You can offload that into a dedicated Juniper appliance to deal with that. So we of course support the offloading into that, so you can correlate that also with your physical and with your servers and with every other thing that could be creating logs or events. The Firefly host is all IPv6 capable, so the management as well as the firewall enforcement is all IPv6 ready. So that has all been tested and validated with the various labs. This is also has a common criteria CCEAL2 cert on it, so those government deployments and so forth are possible. Okay, so now I'm going to go ahead and drop out of the PowerPoint and actually just log into a couple elements to show you the product live here. So let's first of all take a look at the virtual infrastructure here. So I'm just logged into vSphere client within this window. You can see I have two physical ESX hosts, and they have a smattering of VMs, a couple of web server VMs, and then this guy over here has a couple of app servers, and there's some infrastructure VMs in here. The management system itself is a VM. It's called Host Demo. So this is the Firefly Host management VM. You can see here it's 2 gig of memory and not doing very much. A single virtual CPU attached to it. Each host, you remember that orange box or that SVM that I was talking about? There's one here, and there's one on this host as well, right there. And you can see this guy is pretty lightweight. It's not doing a whole lot. It's just a gig of memory that was allocated to this one, and you could log in here and actually do there's a shell that you can run and do things, but by and large you don't ever have to do much of that. There's also, if you look at the host itself in the configuration screen, you'll see a bunch of vSwitches, your standard vSwitch zeros and ones and so forth. And also, the only thing that's maybe weird to those VM admins is this VM service vSwitch. So this is how we communicate with the kernel module and how we inject the kernel module. So we create this vSwitch automatically, and we actually create the SVM automatically, and everything that you have to deploy to kind of lay the plumbing, if you will, to start doing security on a host. I'm just showing you the details so you get a lay of the land. What I'll do now is I'll flip over into the actual web interface. So I'm just going to log into that host demo VM via its web interface. Here, I'll get logged in, and you can go right to the installation area. Show you here is the credentials of the virtual center and the password, the IP address and the username and password for virtual center. This allows me to come to this screen and be able to click here and see the host. So in the background, we made a VI API call. What are the hosts that you see? Well, there's these two hosts and they have these VMs on here. This is an already secured environment, but if it was a fresh environment, you would just select the host, hit secure. We would deploy the VM service vSwitch. We would deploy the SVM. We would configure everything that we needed, and then you could start selecting what VMs you want to actually protect. In this case, I've selected all the web servers, but say I didn't want this web server, I could hit unsecure, and it would just remove the association with the Juniper Firefly host product away from that VM. So very easy to deploy the solution, just kind of a point and click process. So let's back up to the main interface. This is just kind of your high level overview of what's happening in the system, a compliance, some IDS alerts, so forth. You have kind of an events and alerts page here, some different auto config pieces that we're alerting on. The quarantine area, we don't have any VMs that are quarantined on this setup right now, but if you'll see in the product various modules, you can take a quarantine action. If you don't like a VM being connected to a promiscuous mode port group, you can raise a compliance alert, and then as part of that alert raising, also quarantine that VM that's connected to a promiscuous mode port group. You would see that VM in here, and you could build a quarantine policy that defines what happens. What does it mean when you quarantine a VM? Well, it means they can't connect to these networks, and all you can do is RDP to it, and that's it. A set of rules that you would create from the firewall perspective on quarantining a VM. Right now, the quarantine policy is very restrictive. It's basically anything in both the inbound and outbound direction, reject it. But you get the idea. You have a quarantine and a way to kind of access that and manipulate that definition. First module I'll show you is the networking module. So because we're in the packet path in between the virtual NIC and the virtual switch, we see everything. A byproduct of that is like, hey, we have to be there to do the security, but we're there so we can kind of report on the activity. And so this is just a snapshot of what that VM is doing. You can see top protocols, the talkers, it's VM to VM communication, VM to physical. As long as it's one half of the connection, we're going to see it. We dump that in the database. You could drill in on an individual VM. So I could come in here and look at this particular VM and say, well, Firefly Win 7, this guy is basically, this is a Windows VM in the Firefly environment, and it's been doing this amount of traffic, and here's some information around the IPs and the MACs that are configured on it. It's the information in blue is stuff we query from Virtual Center, so we know the CPU usage right now and the memory and so forth. So some visibility into what's happening. I will say we have a very small environment, but if you look here at our searching pieces, we have a lot of elements here. So I could say, something like that, and boom, I can instantly find the VMs that map up to a certain thing that I'm looking for, right? So, I can find that VM pretty quickly. Next, I'll talk about the firewall module itself. So the firewall is composed of global, group, and individual VM policies. So in this screen right here, the first thing to notice is like, okay, so it's a global policy, so this is obviously going to every single VM that's protected. It's broken into the inbound and outbound direction. Now that has nothing to do with statefulness. The firewall is completely stateful. You can put a stateful rule at the top and not have to build an outbound rule for it. For example, a data connection on FTP or something like that. But the idea was to make it simple. Just think of the flows coming into the VMs or leaving the VMs, and then you can go and adjust rules based on that. We have some sandwiching that we do. It's top down. It's always top down order of execution. But we have a lot of flexibility in the way we can manipulate which rules come into play. So this is normally an any reject. It was set to allow just for some testing. But normally the rule base would look like something like this. Like if you explicitly accept it, then great. If not, I don't know what it is. That it must be, I'm going to assume that that's something that you don't want. So the rule editor is flexible in that way. I'll show you a cool thing from here. I'm going to not save my changes, but I'm going to show you a couple of different types of groups to help understand how we build this. So we have two types of groups. So there's a static group where you would just come in and you could type in web servers, and then you'd go through here and you'd pick out the web servers, right? And then put them in that group. And if in this case, there's 3 of them, but if a 4th one came online, you'd have to go back in here and put the 4th one in a group. But that's not a very efficient way, and in the virtual world, we can do things better, right? That's a very physical way to think about making a group. In the virtual world, we can actually say, well, if the name contains web, then if number 4 was there, it would just automatically show up there. So we've created a group like that, this web servers group, and you can see web servers. If the name contains web, then make it a policy group, and I can test, and I can see there's these 3 members in it, right? So now when I build my policy, I can see in my policy groups this group web servers, and if I look at it, it's got 3 members in it, and if a 4th one came along, it would instantly be in that group. But now I'm clicked on this group policy for web servers, inbound 80 and 443 allow. That's as simple as it is. So now any web server that comes on, inbound 80 and 443 are going to be allowed for it without any scripting, without anything complicated. We just took the name of the VM and put it on there. Okay, so the firewall, a couple other things about the firewall. If I wanted to do, it's a web server, but this guy's also going to be allowed to do, FTP, right? So I'm going to say, go ahead and do FTP, and I would do an allow. And if I save that, I can do a show all here. And with the show all, you get an idea of the sandwiching of the different types of policies that we have. Global, group, individual VM, you sandwich them together, you make this policy to do exactly what you need it to do. And that is a really powerful policy editor. In the 5+ years I've been dealing with this product, there's not cases of customers where they can't build the rule set that they need to map to the flows that can be quite complicated in the middle of a data center. Flexible policy editor for all kinds of different flows. So I changed the policy on the VM level for web server number 2. So what it's saying is like, you need to push that policy. So I'll just push it. So now I'm pushing the ability to add FTP to a single VM. In fact, a single VNIC. If it had multiple VNICs, it would be out to that single VNIC. So it goes back to that architecture diagram I was showing you, and the separate connection table and the separate kind of rule base that is instantiated for that VM. Of course, I don't have to do it one by one. I could do it for all the machines just as easy, right? But you get the idea that it's a very granular ability to control at the host level. And then, of course, there's logs. So firewall logs that are native in here on the log. You can apply filters and lots of powerful things to go and find exactly what you're looking for from a logging perspective. But let's take a look at the next module, which is the IDS module. So right now there's only one little alert that's happened. This is actually a custom signature. So you usually would see high, medium, low style alerts in this screen. I actually wrote this signature here, and we can see all the sources of traffic that are involved in this. So the source of this IDS alert was Firefly Win 7. It sent out a PHP access attempt. And so what I'll do is I'll show you that set of IDS alerts, so you get the idea. There's alert sources and targets and the type of alert all available in these screens. But setting up the actual signatures is done in this screen. This is the signature that was triggered right there. This is a very simple signature. You can cut and paste from our standard signatures to create your own, right? So this is a custom signature, and down here in the subscription area, these are all the ones that kind of just get integrated into the product with constant updates. So we can kind of, go look at the denial of service ones. You can see, you get the idea of some highs and lows. You can click on any of these, see the CVE, the bug track numbers. You could change it, disable it, and say, oh, this is not important, change the priority, and also see the signature. So you could cut and paste this and create your own and just alter it a touch and make it work in the way that you would like it for your particular environment. That's an optional module. The antivirus is also optional. In this case, there's not a lot going on in the AVs. I don't have any threats in the past 7 days. I have 2 different types of AV. There's on access and on demand. One of them is completely clientless. That's the on demand scan. So we literally take a snapshot of the VM, mount the snapshot, and traverse it. So that doesn't. So that means you don't have to have any kind of software installed in that guest VM. With on access, you install a 0.5 mega code, a lightweight, thin agent instead of a big, bulky, full antivirus agent. Those are the 2 differences there. On demand is, of course, great because there's no client software, zero, not even a small client. But it's, from a security perspective, it's only as good as your scan interval. So for an on-demand scan, you would say daily, that's a really good scan interval. But if you did it weekly or monthly, the security's not that good because it's not that often. So that's why we have the on-access. So if you configured on-access, then you could have real-time read-write of a file to disk. We shim that write of the file or read of the file out to that SVM that's on the host where I was talking about before, and we run it through that and figure out if it's clean or dirty, and then allow or reject the write of that file in real time. So that's on access. You can use both of them or one of them or none of them. You can customize what types of files you're looking at. I don't care about stuff in the temp directory, whatever it is. There's some alerts. You can quarantine the file or the VM. You can even suspend the VM or just create an alert. All of that's configurable with the scanner config. In a similar fashion for what I talked about with the on-demand AV, taking a snapshot of the VM, mounting the snapshot, traversing the snapshot, we have that same concept for something we call introspection. Now, with introspection, what you're going to do is take a similar type approach where you define a set of VMs that you want to have scanned and kind of things that you want to have happen on that scan, alerts and so forth. And then the system starts scanning the VMs, taking a snapshot, mounting the snapshot, traversing, and instead of looking at files and comparing them to a signature database, by the way, we use Sophos in the back end for the AV, but instead of doing that, what it's doing is saying, what's the applications that are installed there? For example, Firefox, right? So if I wanted to say, Firefox, I can see that, I have this version of Firefox installed, and there's only 3 VMs that have been scanned like this, Windows Server, Windows 7, and then a Linux version. Space is actually a Linux platform, so it can pick up Windows or Linux and give you some information around that. So a cool way to use this is to say, well, right here. So I can click on that VM and see everything that's installed in this VM. I can also go to Image Enforcer and see applications that have been added or removed. So let me explain the Image Enforcer concept. So we have this introspection technology. We're looking at the contents of a disk, of a VM, applications, operating system, service pack level, so on and so forth. And we're doing that at a snapshot in time. So you set up an enforcer and a set of VMs that are going to get scanned, and then we scan it. And the cool thing that you can do is you can say, well, I want to create an image, a master image, a template, for example. And then I want to, on day 1, all my VMs are built off this template. On day 180, I want to make sure they all look exactly like that template. And so with Image Enforcer, you can say, here's my group of VMs. Here's the template, or maybe a master VM. I want all the VMs to look like this. And if they deviate at all over time, I want to see that deviation. And in this case, there's no deviations. Everything matches 100%, and so it's all green. But if somebody added or removed an application, then I could instantly spot that, and I could quarantine the VM or take different behavior changes for that. So that's introspection. The cool thing about introspection is you can actually use that in that smart group technology I was telling you about earlier, right? So if the vf.application contained Firefox, and then I could make a group or take some kind of function and do something to that, right? So if somebody keeps installing Nmap, I can quarantine that pretty easily. If they're running Nmap, then put them in the quarantine policy and take them off the network. Okay, so that's introspection compliance. The last modules. In the compliance engine, we have a bunch of predefined rules here that we get from VMware Best Practices, DISA, and some other sources. But things like this one example, no promiscuous mode port groups. So this basically says VMs, the hardening guideline says VMs shouldn't be installed or connected to promiscuous mode port groups. So we have a way to actually go in there and figure out if somebody's connected to a promiscuous mode port group. If they are, then you can raise an alert and say, hey, this VM shouldn't be connected like this. So here's Win7. It's actually not connected. It's passing that alert. So everything's fine with this one. It's failing a bunch of other stuff. And so you could come in here and drill in on that and see exactly what does that mean. The great thing about this is that you can create compliance for your organization. Your organization says no pink VMs in the green network. And that kind of rule can be created in a couple of clicks. And then the compliance monitor really starts to lend value to your particular organization. The last module here is a reporting module, and I have a sample in here, PDF, CSVs, email it out, keep it local in the system, run it every day, run it just now, run it once a week, whatever. You have all these kinds of things that you're seeing in the GUI you can create reports out of, and then run that report or have the system email it to you. You can click on the report and see, here's the report. It's got, here's the traffic that happened, all the information that you would see in the GUI, so you don't have to be constantly going into the product. There's a few items in the settings area for doing updates. All the updates can be automated for configuring any of the actual system attributes, IP addresses, or any of those sorts of things. Even some ability to view different system logs. So again, you don't have to spend very much time on the system under the covers, right? It's pretty much all driven from this user interface. So that's the demonstration of Firefly Host. And I'll just last set of slides. It has a couple of places for you to go. The software can be completely downloaded, no problem, off of juniper.net. And there's a couple of URLs here to get in touch if you have further questions. Thank you.